Before we watch Nikita fire the potato gun, let's take a look at the physics behind projectile motion. Let's define v0 to be the muzzle velocity of the gun and theta to be the angle at which the gun is elevated. Now, to determine v0, we had to take a close-up of the gun firing. We marked off 2 points on a broomstick 40 centimeters apart and measured the time required for the potato to pass through the points. Pretty quick, huh? Let's watch that again a little slower. I won't bore you by counting frames, but the velocity of the gun is approximately 50 meters per second. Therefore, we know that Vx, our x component, is 25 meters per second because 50 cosine of 60 degrees is 25, and Vy, our y component, is 43.3 meters per second because 50 sine of 60 degrees is 43.3. In real life, air friction plays a huge role in projectile motion. But if we are to ignore it, then Vx will be constant because there are no forces in the x direction, while Vy will have a constant negative acceleration due to gravity. These two pieces of information allow us to find the maximum height attained by the gun and the distance it fired. Now let's watch Nikita fire the gun. In this shot, we will witness a potato fly high into the sky. Using our kinematic equations, we can find the maximum height and maximum distance the potato will fly. The two equations we will need are position as a function of time, which equals the initial position plus velocity times time plus 1/2 acceleration times time squared, and velocity as a function of time, which is equal to the initial velocity plus acceleration times time. Compiling our list of known variables and constants, we see that our missing variable is time. Now on to the equations. First, we're going to find the maximum height that the potato will fly. Using our velocity as a function of time equation, we plug in the velocity in the y direction and acceleration due to gravity to find that the time it takes to reach its apogee is 4.42 seconds. Using our second equation, we plug in our other known variables and find that the maximum height attained is almost 96 meters. To find the maximum distance, we once again use our position as a function of time equation. Since there are no forces acting in the x direction, we know that there is no acceleration. Taking our time found to reach the maximum height, we multiply that by 2 to compensate for the potato falling out of the sky, and substitute the remaining variables to find that the distance reached is a whopping 221 meters.
On you. Gotta hold it.
Three, two, one.